Okay, we're going to talk about conic sections in this chapter. We looked at a couple of things yesterday dealing with midpoints and distance formula, but today we're going to look at parabolas. We've looked at parabolas quite a few times, but we're going to look at them from the context of conic sections. A conic section is basically when you have a cone on top of a cone like we have here. What are all the different shapes that are formed when you slice a cone? Well, if you slice a cone horizontally, you get a circle. And we've looked at circles before. We'll look at them again the next lesson. We also, if you slice it a little bit diagonal, you get what's referred to as an ellipse. Slice it even more diagonal, you get what's referred to as a parabola. Slice it pretty much up and down, you get what's a hyperbola. On this graph, it looks like a parabola going down and also one going up, but it is a slightly different shape that we'll be getting into. Slice it right in the middle, you get a point. Slice it right on the edge, you get a line. Slice it straight up and down, you get intersecting lines. Now, for conic sections, it's really just the first four that have concerned a lot of people. But in here, we're going to focus only on circles and parabolas. Now, here's another example of two cones and how they can be cut. And I just thought I would show this one to you so that you'd have a different point of view compared to the last slide. Now, we've looked at quadratics before in this form here, and we know that when we graph that we get a parabola. Now, parabola is really, by definition, a set of all points in the plane that are equidistant from a given point, which is called your focus over here in red, and your given line, which is your directrix, which is given over here. You're looking for all the points that are equidistant in between. Well, this point right here is halfway in between. This point right here is 2 units to the right of your vertex, but also 2 units straight up. This point over here, the distance going straight up to that point is equal to the distance going diagonally to your vertex. And the same idea with all these points over here. They're all the same distance from your directrix to your focus. When you graph all those points, you get this blue shape, which we call a parabola. Now, there's also a special green segment in here. The parabola is just the blue. The green segment is called the latus rectum, and the length of that latus rectum is 1 over a. But since it's length, you need to make sure it's positive, so it's absolute value. Now, on this screen, you need to remember a couple of things. You need to remember that the distance from your vertex to your focus, meaning this distance right here, or the distance from your vertex to your directrix, this distance right here, and you know they're the same, is 1 over 4a. You also need to know that the length of your latus rectum is 1 over a, absolute value. Also, this is your vertex form of your parabola. If a is positive, it opens up in the positive direction. If a is negative, it opens down in the negative direction. Parabolas can also open sideways, and that would be this equation here. H and K is still your vertex, just like it is over here. If a is positive, it opens in the positive direction of the x's, which is to the right. If a is negative, it opens in the negative direction of the x's, which is to the left. So here, this is if you're opening up or down. This one's if you're opening right or left. So let's go ahead and take a look at this one here. Here's your parabola. We need to go ahead and find your vertex, axis of symmetry, focus, directrix, direction of opening, and the length of your latus rectum. Plus, we're going to graph this. Now, we know this is a parabola that opens sideways, because here your x is to the first power when your y is squared. Whenever your x is the first power and your y's are squared, you are opening sideways. Here's the general form of a parabola opening sideways. Same one that was on the previous page. Your vertex is still hk. So what do we have to do with this to get it into that standard form? We need to complete the square. So we need to get x by itself, so we got to get everything over the y, so subtract the y squared from both sides. And now we're going to go ahead and complete the square. We're going to just group the y's together. Remember, in completing the square, the number in front of your square term has to be a positive. So I'm going to factor a negative out of the parentheses. And so that's why this becomes a negative here. Now, we have that. In completing the square, we need to add that half of b squared to both sides. So you got to take half of 4, which you know is 2, and square that. Now, in this case, instead of adding it to both sides, we're going to keep it all on the same side. Because if we added it over here to get x by itself, we'd have to subtract it over here. And so that's why we are subtracting this stuff. What we put here was a 2 squared. But this 2 squared here is really multiplied by that negative in front. So you're going to be putting half of b squared here, but then you're always going to be subtracting your a value, what's in front of your parentheses, times what you put in the parentheses. So now we are going to simplify this. At the very end, we get plus 3 from this. Remember, the parentheses here factor into 2 identical parentheses. What's being squared in the beginning is, oops, sorry about that. What goes in the beginning is always the squared number. What was being squared. What goes in the end is always what's being squared at the end, which is just a 2. So, we know we are opening left or right, but since your a value is negative, it's going to open in the negative direction of the x's, so it opens to the left. Your vertex is always hk. H is always the x-coordinate, k is always the y-coordinate. When you're looking at parabolas, it's always the opposite of what's in the parentheses and the same as what's on the outside. So your x-coordinate's the same as what's on the outside, which is the plus 3. K is your y-coordinate of your vertex in this case. So it's always the opposite of what's in the parentheses. The opposite of a negative 2 is 2. So you have your vertex. You know you're opening to the left. You could go ahead then and choose, since you're making a t-chart, going to the left or to the right, you want to find your x's that correspond to your y's. So we have our y-coordinate of our vertex, and we put that here, and you choose 3 numbers on each side. You could also use the pattern of over 1, up 1, over 1, up 3, over 1, up 5, and so on. But keep in mind, you got to flip that a little bit because you're going sideways, so you go up 1 over 1, up 1 over 3, up 1 over 5. When you complete your t-chart or use the pattern of your 1, 3, 5, 7, and so on, you get a graph that looks like this. Now, your axis of symmetry is always the line that cuts your graph in half. It's opening sideways, so it's going to be a horizontal line. In this case, it's a horizontal line at a height of 2, so it's y equals 2. It's always going to be the line that cuts your parabola in half, and it will always go through your vertex. The y-coordinate of your vertex was 2, so your axis of symmetry was y equals 2. Now, your focus is always on the inside part of your parabola where it's curving around. Your directrix is always on the outside part of your parabola. It's always perpendicular to your axis of symmetry, and it never touches or crosses your parabola. Well, we need to go ahead and figure out how far in we need to come or how far out we need to go to get to your focus or your directrix. Remember, that's always that 1 over 4a. Now, a is that negative 1, but we're looking at distance to the left or distance to the right, so I'm going to treat it as a positive because we know distance is positive. So your a value is negative 1, but we make it positive because we're dealing with distance. Plugging it into our formula, plug in 1 here, you get 1 over 4. So we need to go a fourth of a unit to the left. Now, remember your vertex is right here of a 3, comma, a 2. You need to go a fourth of a unit to the left of that point. Well, if you're going just to the left, that's only going to affect your x's. Since you're going to the left, it's going to make your x smaller, a fourth smaller in this case, because that's your distance. So we get 11 fourths, comma 2. Then we have our directrix over here. That's a fourth of the unit to the right, so you're going to have to add a fourth to this because you're going to the right for your x's. Also, the length of your lattice rectum is always 1 over 4a. So that's going to be 1 over negative 1, absolute value, so you get 1.